channel, and today in this specific session we are going to solve some very different, important and very unique type of previous year gate questions on operating system. Why it is needed? Just because PYQs are the role model questions of gate examination, and if we learn from PYQ, we revise the concepts, how we solve the questions through these concepts. If we learn that in the last time, of course many of the questions we can get in next gate examination from these concepts itself, and that is why this particular session is gonna be very important for all of you. Quickly just confirm if my audio and video is clear, or both the things are clear for you guys, so that we can start the session for the day. And quickly, without any delay, just keep your pen paper next to you and tell me if you guys are ready for learning today, so that we can start the very first question of the day. I am telling you, this particular session is not about increasing your practice or helping you guys in the confidence that I can make all the question, etc. This particular session is all about learning the concept appropriately and applying the concept appropriately. If you can't solve all the questions, don't worry. If you can solve many of the questions, very good. But here the motive is not to get the correct answer. Still the motive is to learn how to solve the question using the knowledge we have. So do not worry if you are not able to solve the questions. Don't get nervous. This is what the part of learning we are having. So don't worry, just continue till the end. Okay, quickly, if you guys are ready, confirm in the comment box you guys are ready for the learning. Go. I want your message in the comment box. You guys are ready for learning today, so that we can start the very first question. From the very first question, see, the thing is, you guys always demand those questions which you cannot make sometimes, or where you are having trouble. What we understand is gate examination. What I have brought is those type of question which are probable, such that such kind of question may come in this year gate examination also. Doesn't matter, among these your choice of PYQs are not there, but you are not expert, I am. That is why I have brought these questions, not your favorite PYQs. Okay, so here is the very first question of today. A lot of things are given here, just check it out. So it's a question of, subjective type answers. The new status of the list, page fault, how many, and page replacement, if any, how many and how. Exactly all these things you will have to tell me at the end. And let's go solve this question. Look at this. These are hexadecimal addresses. These numbers are in decimal. Are you guys understanding how to solve this question, or should I help you? Trying? At least trying? It 1996, before your birth. Fine, okay, I'm waiting. Tool and timer. 2 minutes from here. 2 मिनट यहां से आपको हम देंगे. I'm gonna give you 2 minutes from here. More minute from here. Mayur is having a question mark at the end of the answer. Mayur, answer if you give, then you do not have question mark at the end. If you are giving question mark means you are not confident. Okay. Fine. Whatever has happened, happened. Let's try to solve this. Demand page virtual memory system has 16-bit virtual addresses. 16-bit addresses in hexadecimal 4-digit. That's why these addresses are 4-digit. Fine. Page size of 256 bytes and 1 kilobyte main memory. LRU page replacement is used using the list whose current status is something like this. This is the least recently used. If this is least recently used, then most recently used is this. So we have used page number 17, after that 1, then after that 63. So 63 is just now used page. For each hexadecimal address in the address sequence given below this, what happens? You tell me, page fault or page hit. We take from virtual address or page number. We have the page replacement policies and all other things applied on the page number or virtual address. Of course, page number. So from these virtual addresses, I'll have to take the page number out. For that, what I'll have to do is divide the logical address of 16 bits into two parts P and D. How many bits in P and D? Page size is 256 byte, 256 to power 8. So 8 bits here, 8 bits in page number. So here page number is what? I am taking out from here page number. Page number here is 1, 2, 3, 4, 1, 2, 3, 4, which is nothing but page number 0 in decimal. Here is 0 and 1. So 0, 1 is 1, 2, 3, 4, 1, 2, 3, 4, which is page number 1. Next, page number 10. 10 is 1, 2, 3, 4 is 1 and then 0. 10 of hexadecimal is actually 16 of decimal, page number 16. And here is 1, 1. Of course, 1, 1 will be 17. So these 4 pages CPU is referring one after another, page number 0, then 1, then 16, then 17. Currently 3 pages are already there in the main memory with this list. 17 page number 1 and page number 63 are already there in the main memory. But how many page we can keep in the main memory? How many? As many as frames we have. But how many frames we do have in the main memory right now, we don't know. Not given directly in the question. I'll have to calculate number of frames main memory size 1 kilobyte divided by page size 256 byte. Answer is 4 pages. 4 pages we can store in the disk, sorry, in the main memory right now. Why? Just because we are having number of frames 4. If you don't want to go with this one, you can go with the physical address format also. If you go physical address format, 10-bit format, how? 1 kilobyte main memory, D is 8, so F will be 2 bits. With 2 bits, 4 frames you can have. Now, among 4 frames, 3 already we have, pages 17, 1 and 63. Okay, so what I'll have to do is add a page over here. My current status is something 17, 1 and 63 are already there. When there is a request of page number 0 at first place, I'll have to have a it. So page number 1, sorry, page number 0, it's a page fault. Page number 0, 1, 16 and 17, that is the request. 0, it's a page fault. We bring 0 into the main memory with the page fault. Empty frame we have, yes, empty frame we have. Total 4 frames were there, 3 pages are already available, 1 empty frame, done. Now page number 1, it's a fault. No, it is a page hit. Why? Page number 1 is already available. Now page number 16, a page fault, yes. Which page you will remove? Page number 1, recently used. 0, recently used. 63, recently used. You will have to remove 17. Replacement, LRU replacement says least recently used page. Least recently means very earlier you have used it. So replace 17 by 16. Next, for 17, another page fault. Which page you will replace? Keep 16, 1 and 0. Replace 63. 16, 1, 17 and 0. What is the current list right now? The new list of the pages is 0, 1, 16 and 17. 0 is my LRU page, least recently used. Fault, how many page fault? 1, 2 and 3 page faults. Page replacement, yes. How many times page replacement? 3 times. No, 2 times only. 2 times page replacement here. 16 replacing 17 and 17 replacing 63. Can you please let me know if anybody is having any doubt or query or question in this particular question? Any kind of thing which you could not understand? Anybody? This question I have asked, why? Just because I wanted you guys to have practice of such question. I am having strong feeling such kind of question may come in the GATE examination in next few years. Exactly not in next year, then maybe next to next year. But strong feeling I do have similar questions can come. If everything is fine, give me a thumbs up and we'll go to the next one. Clear, clear, clear or not? Okay, great. Then next question, here it is. Another virtual memory question it is with TLB and cache and many other things. Many information in this particular question may not be used to solve this specific question. Okay, so just ignore those informations which are not being used to solve this particular question. Two minutes. You all are having 2 minutes to solve this question. Acha, 2.5 minutes. Now solve this question. Ride with 𝐂𝐸08. How do you guys come up with such kind of names, huh? Gate Smasher Karthik. Wow. Any answer anybody getting? Three minutes gone. चलिए और थोड़ी देर. C, B, C, D. Okay, okay, okay. Half a minute more I am giving you guys so that you can think of it. Hey, fine. Let's try to understand how is it. Level page table for virtual to physical address translation. Page table for both levels are stored in main memory. Page tables are all stored in main memory. Virtual and physical addresses both have 32 bits. Main memory byte addressable. Virtual to physical address translation 10 modes based. ये this. This much from here to here. I don't need it. I don't need for this specific question. Further, the processor has a TLB with a hit rate of 96%. TLB caches recently used virtual page numbers and corresponding physical frame numbers. The processor also has a physically addressed cache. What does it mean? Physically addressed cache means the cache memory you can access only using physical address. So first you translate your logical address into physical address. Once you get the physical address, then only you can access the cache memory, otherwise not. So for page table access, you cannot access the physically addressed cache. No. Okay. With a hit rate of 90%, main memory access time 10 nanosecond, cache access time 1 nanosecond, TLB access time is also 1 nanosecond, as I mean page fault occurs, no page fault occurs. Average time taken to access virtual address is how much? Average memory access time is asked here. Okay, now before we solve this particular question, I have explained you guys if TLB and cache both are present over there. First, using the physical address, you just calculate the content access time. When you get the physical address, how much time it takes for the content access, that will be same for all the cases. So I am taking T content access time. Content access time with physical address. When you get physical address, content access time will be how much? When there is a hit in cache, cache memory is access time. When there is a miss in cache, then cache memory plus main memory access time. Hierarchical access, just because we are using the TLB. With TLB, mostly we use the hierarchical access. Doesn't matter, in gate, both are accepted. So first of all, 90% hit rate of cache, main memory access time 10 nanosecond. Based on that, I am calculating this 1 plus 10, 11 nanosecond is my 1.1 plus, oi, how 11? 11 ka 0.1, 1.1, 2 nanosecond it is. 2 nanosecond is content access time for physical address, TCA. Okay, fine. Now we will use the formula, average or effective memory access time. Effective memory access time is how much? When there is hit in TLB, what happens? You access TLB once and you get to know that whether it is a hit or miss. It is a hit. You got the physical address. As soon as you have a hit in TLB, you got the physical address. Once you get the physical address, you will have to access the content using 2 nanosecond here, content access time. Plus, when there is a miss in TLB, in that case, what happens? First of all, you have accessed TLB 1 nanosecond. Now, in the TLB, it's a miss. So you will have to go to page table for accessing the physical address. To get the physical address in 2 level page table, I'll need 2 times of memory access time. So let's calculate page table access time, 2 times of main memory access time. This much will give you physical address. Abhi you will get physical address. Now with physical address, content access time is 2 nanosecond. Me how much the answer is. कितना हो रहा है? How much you are getting? Approximately 3.8. Based on that, to the nearest 0.5 nanosecond, which is 4 nanosecond. D is correct. Virtual nearest 0.5 nanosecond, to that I'll have to, go with answer is D. Chali. Okay, next question. Easy. It is easy peasy. I'll give you only 2 minutes. Done. Arey, it is easy, Ray. Sir, TMM plus TMM content. Babuji, content access time extra में I am calculating ना this 2 nanosecond. ये क्या रहा? There I'll have to check out the cache hit miss ना. Physical address निकलने के बाद after physical address you get. Don't just mug up the formula and use it. Your name is IITB 2 times, but still you are just mugging up the formula, not understanding what is information given, babua. Okay, not more than that now. Done. Two answers A, B. I'm getting one is C, then two answers D, two answers C, A and B. अरे इतना टाइम नहीं लगता है. We don't need such time for this. Virtual memory system, size of virtual address 32 bit, size of physical address 30 bit, page size 4 kilobyte, size of page table entries 32 bit, memory is byte addressable. Which of the following is maximum number of bits that can be used for storing protection and other information? If somebody has studied with me, I always told you such kind of question, if you want to solve, go opposite. What is asked, let's try to understand it, and let's try to understand if there is any formula or format for the given asked thing. Given asked thing is how many extra protection bits are there in each page table entry. When we see the page table entry, this is my concept coming out now. I know, you also know, you need to just know this concept to be utilized. Each page table entry contains what? Frame number and extra bits. Right? Now I'll have to check. Do I have page table entry size given in the question? Okay, ye raha. Size of each page table entry is 32 bit. So this is completely 32 bit. To get the answer for me, what I'll have to do is, if I know how many bits are needed for frame number, I can know how many bits are extra in these 32 bits. Simple. I don't have to do multiple things. So how can I get frame number? Biological? No, physical address. Physical address, how many bits? Physical address 30 bits. F and D. Page size, from page size I'll get D. 4 kilobyte, 2 power 12, 12 bits gone. Among 30, 12 gone here, 18 bits for frame numbering. If 18 bits are remaining for frame numbering, then extra bits, how many? 32 minus 18, answer is 14. That's it. Now, just raise your hand if you have drawn the format of logical address also and made P and D also. How many of you did this? आप में से कितने लोगों ने लॉजिकल एड्रेस का भी फॉर्मेट बनाया? हाउ मेनी ऑफ यू डिड दैट? आई डिड नॉट इवन नीड इट. I did not even need it, but how many of you did it? Raise your hand. This is what the difference. The people who know what to do, directly they will do only that particular thing. That will save your 30 second, 20 second in your question. If similarly 4 or 5 times you can save in each of the question, in such kind of a question, you can save 2 to 3 minutes. Means you will have extra 3 minutes to solve one tough question. That is where the difference is. Practice will make you better. Practice will make you better. Answer is D, 14. That is the correct answer. Whatever needed, only that thing I did. But how I understood this, sir? Reverse approach. Reverse. From here to here you go. Whatever is asked, first go with that. If anything is missing over there, just try to find out those things. That's it. I don't have to go with logical address at all. And that is what you will have to learn by more and more and more practice. Now itself also you can learn it. Okay, next question. Here it is. Another 2-minute question. Sir, my semester exam are ending 22. How to manage? Practice. Write the test and practice. रियल टेस्ट का रिजल्ट आज अनाउंस होगा. यस. कुड यू लिस्ट डाउन ऑल द वर्चुअल मेमोरी फॉर्मूलाज? यू डोंट हैव टू बेटा. And if you want formulas, there is another formula series we are going to have. Apart from that, I do have my short notes already given. Again, this question, if you will go in the reverse order, you will be able to solve it quickly also and appropriately. Last 30 seconds I'm gonna give you. Last 30 seconds. Time is up. Up, 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 up. देखिए, okay, look at this. Computer system has implemented 8 kilobyte pages, means page size 8 kilobyte. 32-bit physical addresses. Each page entry contains a valid bit, dirty bit, and 3 permission bits, and translation. Translation means frame number. If the maximum size of page table is 24 megabytes, the length of virtual address supported by the system is how many bits? Again, whenever I will solve such question, I always go reverse. What is asked? पूछा क्या है? Virtual address. Virtual address is asked. Yes, in such kind of scenario, I know that virtual address, if I have, I divide it in two parts, P and D. Page number and offset. Okay, page number not given. Offset, can I get offset? Page size, yes, 8 kilobyte pages. 2 power 13 byte means offset is 13. I don't know page number. How do I get page number? I'll have to utilize my knowledge and intelligence to connect page number with the given information. Is there anything which is directly connected with my page numbering? Yes, page table size. I know that page table size is equal to number of pages multiplied by page table entry size. Now the thing is, I do have page table size, yes, which is given as 24 megabyte, but I do not know number of pages which I want to calculate to get how many bits are required for P. Number of pages I'll have to calculate. Page table entry size also I don't know. Page table entry size I don't know, not given in the question. Page table entry size not given in the question, but we know in the page table entry size, we have frame number plus additional bits given in the question. Each page table entry contains one valid, one dirty, 3 permission bits. One valid, 1, 2, and 3, 5 bits extra. F plus 5 bits. Now, the thing is, if page table entry size is this much, frame number I don't know. I can get it easily by the physical address. Physical address, 32-bit physical address. 32-bit physical address, F and D. D is 13, so F is 19. Let's put it over here, 19 plus 5, 24 bits. One page table entry is 24 bits. I'll put it over here, 24 bits. But the problem is, This is given in bytes. This is given in bits. In the childhood, we have been learning this since childhood that if two different quantities we are putting up together, their unit should be equal. Let's convert this byte into bits. So I'm writing 24 mega into 8 bits. 24 to 24 cancel. Bits to bits cancel. Number of pages will be equal to 8 mega. 8 mega 2 की power 23. Number of pages 2 power 23. Hence page number will require 23 bits that I can use here. 23. 23 plus 13, 36 total. 36 bit. एक्स्ट्रा बिट में ट्रांसलेशन भी है बेटा, वो एक्स्ट्रा बिट नहीं है, ट्रांसलेशन इज फ्रेम नंबर. This is what the learning we have in the classroom. That translation means logical to physical address translation is done with the help of page table entry frame number. So translation is frame number. Okay, another question. Should we go for next question then? Again, I started from bottom. Whatever was required, connected information from bottom to up I went, got the information, put it over there and get the final answer. It's very easy now. Most of the students make mistake at one place here. Rather than taking this as byte and bit, converting into each other's unit, they directly take it. And because of that, they get the wrong answer. General aptitude will be on Sunday, 19. Single session we will be having starting from 12 p.m. afternoon. This question is so easy, so easy, so easy. Hardly it takes 1 minute. 2018 GATE paper. E A B B B B B B B B B B B B B B. Not more than that now. Okay, stop. Let's see. A process executing on an operating system that uses demand paging. Average time for a memory access in the system is M unit. If corresponding memory page is available in memory. Clear cut mentioned that if page is available in memory, average time is M. Everything it includes, page table access time, etc, everything. When page is available in memory means no page fault, M time needed. D units if the page access causes a page fault. So if page fault is there, D time, no page fault, M time. It has been experimentally measured that average time taken for a memory access in process is x unit. So effective memory access time is x. Which of the following is correct expression for page fault rate? So we can say when there is no any page fault, at that time m time needed. When there is a page fault, d time needed. This is what given when no page fault, page is available in memory, m time, page fault, d. P is the page fault rate. Overall effective memory access time is x. Now I'll have to calculate value of p. That's it. Equation very simple, just simple formula direct. X is equal to m minus pm plus pd. We'll take m that side. So it becomes x minus m is equal to, pd it is, sorry. I'll take common p from here. So it is d minus m p. From here, p is equal to x minus m divided by d minus m. And option B is correct. This is the page fault rate p. Itna easy. That much of easy question it is. 2018. People said this paper was tough because of such question, and this just 4 steps. That's it. Nothing else. Okay, another question. 2020 virtual memory question. Another formula based question. Multiple type of answers are available for this question. You can see what answer is yours. But the answers already 2.5 minutes gone. This is very popular question. We discuss it a lot in the classroom. Many a times you guys discuss a lot in the practice questions and your telegram groups also. No answer at all? No answer? अरे यार ऐसा मत करो. Don't do it like that way. Okay. See, The question says one level of page table residing in memory, TLB is there, main memory access time 100 nanosecond, TLB lookup time 20 nanosecond. We will put up the formula simply. TLB hit and miss at first place. What is the hit rate of TLB? 95%. When TLB hit 95%, you will access TLB once. After accessing TLB, you get the frame number directly. No page fault occurs when there is a TLB hit. When TLB hit, no page fault occurs. Okay, if that is the case, then directly you will go to main memory, access the content, and that's it. Done. This is TLB hit. Now, when there is a miss in TLB, 5% time. First of all, you access TLB to get the TLB miss. After that, you accessed main memory to get the page table accessed. Now there are two options, either page hit or miss. So two options. Page fault, page fault rate, how much? Page fault rate is 10%. So 90% page hit and 10% page miss. Page fault. Okay. 90% when page hit means you got the physical address. You'll have to access main memory once and done. You got the content. But if there is a page fault, then what happens? Page fault is there, then you will have to bring the faulted page from disk to main memory. Anyway, you will require 5000 nanosecond. And after that, you will have to update the page table 100 nanosecond required. But when 20% of the total page fault dirty page has to be written back, means among the page fault 20% time when dirty page is there, then you will have to have a write back of dirty page 5000 nanosecond, 20% time extra needed. This is the formula you will put up. Calculate how much is the answer. 5000 into 0.2 thousand plus 5000 plus 100, that's 6100 into 0.1 610 plus 90 plus 120 into 0.05 plus this 155. Now look at this. In this particular question, when you will have the official key, it was given between 154.5 to 155.5. Whatever answer you get, you will be having the correct answer. Why this much? So many people are saying that we will not require this 100 of updating the page table. That's why 154 point something. Some people are saying that I'll require 10 more here itself. Why? Just because for replacing a page, we will require the page table access multiple times. So that is why, different concepts, different, thinking, and because of that different answers, that's why they say everything is okay. If you are appropriately fine here and there somewhat, fine. And that is why I told you in the last class when we were doing the Maha revision, these formulas are not standard that this is the only answer possible. In these formula, there are some changes possible. And that is why these gate people are always giving you such kind of an option. So do not worry that this formula, if we are using, same answer only we will get. Somebody will use some other formula and will get different answer. Don't worry about it. Okay. Fine. Let's move to the next topic, which is related to synchronization. Very easy. PB. This is so easy. Synchronization statements can be inserted only at point W, X, Y, and Z. Which of the following will always lead to an output string 00110011? See, 00 means I need to execute P first, then Q, then P, then Q. Just because P is printing Q 0 two times and Q two times. 001100110011. So it is something I'll have to run the processes P and Q in strict alternate manner. But first I'll have to start with P to print 0. If I'll have to start with P, I'll have one wait function here of a semaphore which is initialized by 1. Okay, and another wait function when I'll be having here, that should be initialized with 0. So PS at W, S, VS at X. No. Okay. See, again, whatever weight I am writing here, signal of this particular semaphore I'll have to write. So that once P runs, signals this semaphore, and this semaphore can run wait and signals this semaphore. So option A is gone. Option B, PS at W, fine. VT at X, PT at the Y, and VS at Z, fine. S is initialized 1, T is initialized with 0. This is true. Correct it is. We have seen it in the classroom also. Whatever semaphore you write, wait function of PS if you are having, S initialized with 1 so that PS can run successfully initially. Then V, signal of another semaphore T you are doing, whose P is here, and similarly T is initialized with 0 initially so that PT cannot complete initially until this P process comes and completes this VT. At the end, this process signals what? Signals S so that again PS can run in process P. So option B is correct here. Similar question came last to last year or last year, I guess, with 3 processes. BCA had to be printed. 3 process, and we have seen that question. One semaphore initialized with 1, remaining initialized with 0. This is the question. Amazing it is. Now think about it. This is what will open your mind. If you guys are okay reading the question, I'll show you the options. Options are here. Question says that the string never contains a substring this. These substrings should not be present. These substrings should not be present. I'll give you half a minute more, not more than that. Few more seconds. Are you guys understanding what exactly happening over here? See, exactly what the question says. Same processes P and Q. P is printing 2 times 0. Q is printing 2 times 1. This question says that I just do not want between two zeros any number of 1 printed. But you tell me, how is it possible? Between two zeros, a 1 can print. How is it possible? If both the processes can enter into the execution concurrently. If let's say P process is running, after running this much, after printing 0, if P process preempted, Q comes and Q also can enter and print 1 many a times. Then again 0 printed in the P process after preemption. Then between two zeros 1 can print, or vice versa. Between two ones 0 can print. So how is it possible? Both Q and P can enter for printing. So what they say in the question, these two substrings should never ever occur, which means if P process already entered for printing, Q should not enter for printing at all. And if Q has entered, then P should not enter. Simple, one variable solution will work. Same type variable, you just write PS over here and VS over here. That's it. Single variable solution will work at a time. Only one process will run. Two times either 0 will be printed or 1 will be printed. That's it. So these will never be printed at all. Single, simple variable solution. C option is correct, and that's it. Yes, C option is correct. Rest all are having problem. What is the problem? Problem is if both the semaphores are initialized with 1, then concurrency will be there. If concurrency will be there, means P and Q both can enter for printing. These strings will be possible. And I just don't want these strings to be possible. That's why. See, look at here. PS at W, VS at X, then PT and VT. If two different semaphores are there, S and T both are initialized with 1, this comes PS, S becomes 0, printing 0 one time. Okay, preemption happens. This process comes PT. Its PT also is successful and it can print 2 times this. Yes, possible. Of course, possible. So after printing 0, 1 can be printed. Yes. Why? Just because two processes both are able to enter into printing together concurrently. That's why option C is correct over here. Another question. Very easy question it is. This question is so simple, so easy. Conditions are easily understandable. Two Boolean variables are there, S1 and S2. Either Boolean variables are both true, both false, true or false, different. Whatever it is. Look at this. This P1 process is having condition if S1 and S2 both are equal. Then this particular process will stuck here. Here, if S1 and S2 are not equal, then stuck. Which means, if S1 and S2 are different, P1 can enter into critical section. If S1 and S2 are equal, P2 can enter into critical section. Will not stuck. On different value, similar value. But what happens if P1 and P2 are having S1 and S2 different values? P1 can enter into critical section only at a time, and then it will make S1 and S2 equal. What happens in that case? When S1 and S2 are equal, this process is stuck and this process can proceed. S1 and S2 not equal to each other, false. Equal to each other. Then this process can enter and will make S1 and S2 different. S2 is equal to not of S1. Not of S1 means different value. Hence, this is the example of strict alternation. Strict alternation, like a turn variable. Strict alternation, and in strict alternation we know clearly, no progress, mutual exclusion is there. At a time only one process can enter. If S1 and S2 are equal, this process, not equal, this process can enter into critical section. Mutual exclusion is there, progress is not there. Mutual exclusion there, progress is not there. Option A is correct, and that's it. Simple. And similar kind of solution we have seen for the turn variable. Just you'll have to understand how the turn variable works. If you map this on that variable solution, you can easily get to know the solution and the answer without much of the hassle. Another question. So variable P, variable Q. We have two variables over here. Just check out the code first. Here are the options. 4 options. Two answers, Keval Patel A. Two members, Sneha Cs and Minotaku. D, 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 D. Okay, look at this. How does it work? Look at this. Wait, wait, wait. Stop, 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 stop. See, there is no any semicolon I guess you have seen over here. So this critical section and variable p, variable q setting to false is inside this. Variable p equals to false it is, okay? Inside this particular loop. Now you tell me, is it possible to have the deadlock? If yes, then how? Question is all about mutual exclusion and deadlock. Okay, how is it possible? Mutual exclusion. Both the process can enter into critical section easily. How? Just because there is no any stoppage. Variable p is equal to true. Variable p is equal to true. This particular process will stop here until variable q becomes true. This process also comes variable q equals to true. Both the variables p and q are true. Then when variable q is equal to true, yes, true. In the critical section, variable p is equal to true, yes, true. In the critical section, no mutual exclusion for sure. No mutual exclusion for sure. Infinite loop, how is it possible? Infinite loop. Once this particular process enters into critical section, variable q is true, that's why it is entering. This process is coming, that is why variable q is true, and that is why this process is inside, but this process makes variable p equals to false inside the loop. So what happens? Variable p true here, then after executing one time critical section false. This process comes, initially variable q is equal to true. Once this one, variable q equals to false. What happens? Now variable q equals to true, no, it will come out. Variable p is equal to true, no, come out. Done. So no any infinite loop here. But for sure mutual exclusion is not there. Mutual exclusion is not there. So you tell me what should be the answer. Do we have deadlock over there? No mutual exclusion for sure. No mutual exclusion for sure, but deadlock is there, you tell me. Deadlock is there. How is it possible to have deadlock? Before going for another this particular check, variable p it is making false for this process and variable q it is making false for this process. Condition false, they are coming out. No deadlock. डेडलॉक कैसे चेक करें समझ नहीं आ रहा, वही तो बात है. वी विल ट्राई टू मेक प्रोसेसेस स्टक इनटू इनफाइनाइट लूप. This is the only loop possible where processes can stuck into infinite loop. But how is it possible? By keeping variable q true. I cannot do that. Why? Variable q, if I want to keep true, I will need only this process to run again and again. This process should not run, but this process will run. Why? It has already come. So it will anyway run and variable q will become false initially anyway. If one process only comes, only one process comes, let's say only process x comes, variable p is true, variable q is equal to true, condition false. So this process will not enter into critical section at all, will go out just because variable q is not true. So this single process can stuck into starvation if single process comes until other process comes and make the variable q true. So there can be starvation, but there is no any deadlock. Option, which one is correct now? Proposed solution prevents deadlock but fails to guarantee mutual exclusion. A option looks correct here. Another question. This is exactly once. This is so easy question. True patidar. I don't think so. You are from Maharashtra, but still you are writing a statement of Marathi. पाटीदार जी, इंदौर के रहने वाले हो? A. See, this particular question is very, very interesting question. Very interesting. Why? I'll tell you. Stop. Look at this. अरे भाई साहब, तुम इधर आओ. Following program consists of 3 concurrent processes and 3 binary semaphores. Semaphores are initialized. S0 equals to 1. Oh, these stars are not there. S0 is 1, S1 is 0 and S2 is 0. So S0 is only 1. P0 can only have wait initially successful. Wait S1 and S2 cannot run successful. Okay. Now, initially, okay. Now, how many times will process P0 print 0? How many times? At least twice, 2 times, exactly twice, exactly thrice, exactly once. How many times process P0 will run or print 0? See, very simple thing what I can have is, if I run P0 first, S0 is 1, S1 is 0, S2 is 0. If P0 runs, wait S0, successful, 0, print 0, done, release S1 and S2. S1 and S2 release means signal 1 and 1. Now let's run P1, wait S1, possible, yes, release S0, 1. Any printing here? No. There is no any loop here, so P1 cannot run more than once. Done. After that, can I run P0 again? Yes, I can run P0 again. So if P0 run after P1 again, wait S0 possible? Yes, possible. Print 0 possible? Yes, possible. Release S1 and S2 again. S1 becomes 1, S2 is already 1, so release S2 again, 1 only. P1 once executed, there is no any loop over here, but there is a while loop here, so P0 can run multiple times. That's why I have run P0 2 times. Now P2 can only run. P2 can only run. Yes, P2 will run. Wait S2, 0. Release S0, oh, S0 again 1. So there is another chance P0 can run. P0 runs. Wait S0, yes, 0. Print 0, yes, 0. Release S1 and S2, 1 and 1. Doesn't matter. Now P1 and P2 cannot run. Why? Just because there is no any loop here. There is no any loop. So 3 times 0 can print. This is one of the way. But there is another way. There is another way. How? Look at this. 1 0 0. This is initial scenario. Wait S1 and S2 cannot run initially just because these are 0 0. Now P0 will run wait S0. Fine. Print 0. Good enough. Release S1 and S2. When S1 and S2 are released, they become 1 1. Now P1 and P2, if both will run one by one, what happens? Wait S0 and release wait S1, release S0, release S0, 1. Now after P1, if P0 doesn't run and P2 runs, it runs wait S2 and then release S0. Look at this. These semaphores are binary semaphores. On the binary semaphore, if you run a signal or release, 1 becomes 1 only, 1 stays 1 only. So release S0 will be 1 only. So both releases S0 one by one, but S0 remains 1 only. Now P0 comes, wait S0, yes, print 0, yes, release S1 and S2, done. But S1 and S2 release will not help. P1 and P2 will not run again. There is no any loop here. So P1 and P2 are done. If P0 again runs, wait S0, not possible. S0 is 0. Wait S0, not possible. 2 times only this. In this case, only 2 times 0 printed. So either 3 times 0 or 2 times 0 based on P1 and P2 are running back to back, or between that P0 is running. So either 2 or 3 times 0 printed, at least twice 0 printed. Option A is correct. This is the question when I have written my final year GATE paper, 2010. Okay, let's go next question. Oh, this is easy. This is so easy question. You can answer it very easily. Won't even take much of the time. This is the question of race condition. And in the race condition, we have seen yesterday also, if 3 processes are able to access D value, maximum value possible by just having the impact of positive processes one by one, minimum value possible by having only negative impact. So what is asked? Minimum value X is what? Initial value of D is 100. I will just have the impact of negative minus 50. 100 minus 50 is 50. Why? Maximum 100 plus 20 plus 10, 130. Y minus X is equal to 80. Race condition norms are there. ऐसा क्वेश्चन आया तो सब IIT पहुंच जाएंगे. See, the thing is, if similar kind of all questions will come, then too everybody will not reach to IIT. You see GATE 2023 paper. You just check. 2023 paper was very easy. From each topic they have given easiest possible question, but still everybody could not even score 50 plus. Why? Everybody does not even study and remember everything. You feel everybody is studying, but everybody is just faking of studying. They are not studying. And you know, at the end, they are more worried of what? Not of the result. They are worried of, I did not study entire year. Now, how will I justify my bad marks? Everybody will know मेरा पोल खुल जाएगा. Yes, people are there like that. But okay, I am happy that you all are present over here who are sincere students studying a lot. So we will definitely have better score. My marks 24 में 43. Should I do? What should I do? अभी ध्रुव पाटीदार अभी क्या करेंगे 70 प्लस लाने के लिए? पूरा ईयर क्या करना चाहिए था ये तो देखना है भैया. पूरा ईयर भी तो करना था ना, कुछ तो किया होगा पाटीदार जी, कुछ तो किया होगा. पंद्रह दिन में ऐसा थोड़ी कुछ हो जाएगा कि 70 प्लस डायरेक्ट आ जाएंगे. हाँ, तो कुछ किया है ऑलरेडी, तो फिर इतना चिंता करने की जरूरत क्या है? वाई टू वरी अबाउट? If already you have done a lot of things entire year, just practice and write the mock test. Continue that. First of all, you just check out this particular code. After this, I will show you the options. Not getting more than 55 in any mock. Where are your 45 marks? Where are 45 marks? You will have to understand where you are making mistakes. Identify. Mistake is why. Each and every question you will have to identify. Medical emergency की वजह से 1 month waste हो गया. It's okay. पाटीदार साहब, होता है, हर किसी के साथ होता है. Many people do that, have that. But whatever if you have done in entire year, you can still score well. Write mock, practice, revise. You will be able to do better. I asked, you are from Indore or Gujarat? हाँ जी. These are the options. These 4 options. Gujarat. गुज्जू 6. हम भी गुज्जू ही हैं. एग्जाम में 2 months वेस्ट हुआ सर. 15 days फ्लो रिस्टोर करते करते 10 जनवरी आ गई. अभी भी टाइम है ना, कर लो. Okay, these are the options and this is the question. Stop. Consider the following pseudocode where S is semaphore initialized to 5 in the line 2. Semaphore S is initialized with 5 and look at this, each process or each thread is having 2 weight S, but still more than one thread can enter into count plus plus. This counter plus plus can be accessed by more than 2 threads or at least 2 threads. Why? Just because if semaphore S is 5, 2 processes or two threads can run wait S 2 times. Semaphore S, 2 threads can make wait S, it becomes 3. Another, one thread, then another 1 thread, 2 times wait S, it becomes 1. So 2 thread at least can reach to counter plus plus, means there is a possibility of Race condition. If race condition possibility is there, semaphore S initialized with this counter is 0. What is the minimum possible value? Minimum possible value is impact of only one thread is there. Or maximum possible value is impact of all threads are there. One by one by one. Minimum one. Why? Just because at least one thread will have the impact on counter plus plus. Na? Fine. Now next options. Value of counter is 5 after all threads successfully complete execution on this possible. The value of counter is 1 after all threads successfully complete the execution of possible. Value of counter is 0 after all threads this. There is a deadlock involving all threads. Possible? Yes, possible. Why? 5 threads are there. If each thread runs wait s first one, then all threads will be stuck for the next wait s. Just because s is initialized with 5 threads will take first wait s and there will be a deadlock. Possible? Yes. Option D is also correct. A, B and D are correct. So A, B, D and correct in this particular question. Question was from GATE year 2021. Very easy question. Okay, next question. Here it is. Very easy again, but little tricky. I'll give you 4 minutes to solve this question. 4 minutes. Sir, I haven't revised 6 subjects and completed 9 subjects. Remaining 3 subjects are very vast and have not written mocks, most tests for any subject. Handel suggests Anjali Sahu just leave all the remaining topics. Do not study anything at all. Whatever you have revised, practice them in parallel and write the mock test now. And revise remaining 3 subjects. So in parallel, you will have to do 3 things: revise remaining 3 subjects, practice the completed topics and revised topics, and write the mocks, full length mock. Two and a half minutes gone. One more minute I'll give you. People are doing it. Okay, let me also start this. Processes all arriving at zero with total execution time of 10, 20 and 30 units respectively. Okay, I'll name them processes P1 of ABC. Arrival time 000. Total execution time is 10, 20 and 30. Each process spends first 20% of execution time doing IO. So among total time, first 20% for IO, 20% of 10, 20% of 20, 20% of 30. This much of time each process is spending for IO. The next 70% of time for doing computation means in CPU. Next 70% of 10, 20 and 30. And then last 10% of doing IO again. Last 10% means 1 remaining, 2 remaining, 3 remaining. The operating system uses shortest remaining time compute first scheduling algorithm and schedules a new process either when running process gets blocked on IO or when process finishes its compute burst. Okay. Assume that IO operations can be overlapped as much as possible means all the IO operations can be done in parallel. So for IO operation, one by one execution is not needed. Okay, good enough. Initially, when each process is starting from zero, all processes are doing this. You can ignore now just because IO CPU IO burst is there. For the first two duration of time, there is no any process in the CPU at all. Why? Just because from 0 to 2, the very first process A will do its IO operation finish. B is still in IO, C is still in IO. So now if A is finishing 2 at IO, can run on the CPU for 7 duration of time? Yes, till 9. Till 9 A can finish and after that till 10 it can finish. A finishing its IO till 10. Cool enough. When A was running till 9, what happens? B and C arrives with these two burst times, shortest remaining time, shortest remaining is of B can arrive in the ready state at 4 time, 6 time 9, C arrives at 9 time, both are available and we will continue this. At arrival of B and C, why did not we preempt process A? Just because it was anyway smaller process. Anyway, it is a smaller process, so it will continue. The larger processes are coming after completion of IO. I don't have to have preemption over here. So B will run for 14. 9 plus 14, how much? 23. And then B will complete till plus 2, 25. B IO completed. But during B's IO completing, C will run its 21 time unit, 44 on CPU and after that 3 time unit on IO, 47. So when C is running on IO, there is no any process to run on CPU. At 47 C IO completed. Now all the processes are completing till 47 unit of time. Among 47 unit of time, how much percentage of time CPU is idle? It's starting to last 3. Total 5 unit of time out of 47 is CPU idle into 100%. Answer is approximately 10.6%. Option B is correct. Another very easy question. 2 minutes to go. This is so easy. See, for FCFS, you don't have to solve the question at all. Why? Just because for FCFS, in whichever manner they arrive, they will execute and execute completely. So in the order arriving is arrival of P1 first, then P2 at 1 and P3 at 3. So execution of FCFS is P1, P2 and P3 for sure. You'll have to just run the processes in the round robin with quantum 2. That's it. Let's go with the round robin. For round robin, important part is ready queue. So if you maintain ready queue, time 0, there is only one process P1. P1 we will run on CPU. 0 to 2. Remaining time is 3. When 0 to 2 P1 is running at 2 time duration, P2 arrives, P2 added in the queue, P1 will be added at the end of the queue. So next runs P2. 2 time unit till 4, remaining is 5. Till 4 when P2 is running, P1 is in the queue already, P3 arrives and then P2 at the end. Now this sequence we will run P1, P3, P2. P1 till 6, remaining is 1. Then P3 till 8, remaining is 2. Then P2 till 10, remaining is 3. Then P1 11, P1 completed. Then P2 13 completed. Sorry, P3. After P1, P3 13 completed. Then P2 3 times means 15 and one more time P2 till 16. Like this, processes are finishing first P1, then P3, then P2, 1, 3, 2. This option C looks correct. FCFS, P1, P2, P3, RR, round robin, P1, then 3, then 2. Yes, B and C directly kick out. Yes, of course you can. But still there is not certainty between option A and C. That's why we will have to run round robin at least to have the confirmation. Another question. Very easy question again. Our revision ka PDF is already there on the PW app. If you are in the group already we have mentioned the entire link, etc. PDF will not come to the group. It will be on the PW app. Just go to PW app, there you will get it. We have dropped the links for the Maha Revision PDF. Okay. Waiting for your answers. I remember, yeah, answer 1000 solved many times. Sir, I have covered a lot of subjects back in September, October. I haven't revised till now. My semester exams are going on. What should I do? September, October, after that, what you were doing? You had to revise it before. Now you will have to practice and revise anyway. If you don't do it, you cannot remember. Semester exams always kill a lot of time. I'm still waiting for the answers. Only two answer, three answer, four answer. That's it. Among these many members, only four answers. How is it possible? Answer karo re baba. Akatsu Gaming. ये कैसा नाम? Okay. Three processes. A, B, and C each execute a loop of 100 iterations. In each iteration of the loop, a process performs a single computation that requires TC milliseconds and then initiate a single IO operation that lasts for TIO milliseconds. So first CPU, then IO. It is assumed that computer where processes execute has sufficient number of IO devices and OS of the computer assigns different IO device to each process, so IO operation will be done in parallel. Also, scheduling overhead of OS is negligible. Processes have these characteristics. Processes A, B, C are started at time 0, 5 and 10 milliseconds respectively in pure time sharing system that uses time slice of 50 millisecond. Time in the millisecond at process C would complete its first IO operation. Okay. At time 0, only process A is available. So we will run process A for 50 millisecond. Remaining is still 50. Now, till A was running at 50, process B and C are arriving at 5 and 10 added in that order B and C and at the end A. So the sequence is B, C, A means same to same A, B, C. So I don't have any problem about sequence. Let's run. 100, 150, 200, 250 and 300. 100 each. 300, 150, then 0, 250 and 100. Now, process A can go for IO. Process A will go for IO for 500 times. So, process A goes for IO. 200 plus 500 is 700. Till 700 A is not coming. Till 700 A is not coming. Okay, fine. Now, but still we have B and C. Let's continue B and C. So we will continue B and C. Two times if I'm running 350, 400, 450 and 500. Two times more. This 200, 50, 150 and 0. So when C is done with its TC, it can go for IO 500. So C is completing its TC at 500, will go for IO at 500 plus 500. Its IO will be completed at 1000. That is what my answer. C in the time millisecond process C would complete its first time IO operation is 1000. That is the answer. Okay, another question. This is one of my favorite question. Solved it in Parakram batch. Good. Many questions we have solved already. Here or somewhere. Question says what? Four processes are there with arrival times given 0, 1, 3 and 4. Their length of CPU bus 3, 1, 3 and Z. These processes are run on a single processor using preemptive shortest remaining time first algorithm. Average waiting time is 1 millisecond. Then the value of Z should be what? See, people do what? People consider Z value 1, solve it, Z value 2, solve it, and then based on that they calculate the average waiting time. And they get to know that Z value can be what? 1, 2, 3, 4 or what? Okay, I am not gonna do that. I have explained you before. If well and good, if not, then again I am explaining you. I'll go in the reverse order. I will just limit the total waiting time to make the average waiting time 1 millisecond. How is it possible? Average waiting time I calculate by total waiting time divided by number of processes 4. Average waiting time 1 millisecond. Total waiting time divided by 4. So total waiting time is equal to 1 millisecond. Sorry, 4 millisecond. So total I can have exactly 4 millisecond waiting, not more than that. Let's run the process. At time 0, only one process P1 arrives. P1 runs till one duration of time. There is no any process waiting till 1. Its remaining time is 2. And at one time unit P2 arrives. This P4 is arriving at 4. So till 4 I don't have to worry. Now till P2 or till 1, P2 arrives with burst time 1. SRTF says we will have to preempt P1 and will have to run P2. When P1 is preempted and P2 runs for one duration of time, waiting time of P1 is 1. P1 is waiting for one duration of time between 1 to 2. Just because P1 is not running and it is already in the ready queue. So P1's waiting time is 1. Good. Now P2 completed. Yes. P2's waiting time was nothing. Without waiting, P2 completed. Now P3 arrives. No, P3 did not arrive till now. P3 is arriving at 3. So till now, P1 is waiting 1 duration, P2 is waiting 0 duration. At time unit 2, no any other process is available. So let's continue with P1. I continue with P1 till 3. Remaining is 1. No any waiting time till now. Further waiting time is not there. At 3 duration of time, P3 arrives and P3 is having execution time 3. Remaining time of P1 is just 1. So what happens? We will continue P1. But when we will continue P1 till 4, what happens? P3 is waiting for one duration of time. P3 is waiting for one duration of time. Well and good enough. Now P1 and P2 completed. Yes. Till now waiting time P1 has waited for one duration, P3 has waited for one duration till now. And at 4 we do have two processes, P3 and P4. Which process I can run? Now see, if all processes have arrived, two processes are remaining. Both have arrived. There is no any chance of preemption. So either I'll run P3 or I'll run P4. If I'll run P3, just because its burst time is smaller than Z, then only I can run P3 or equal to Z. Say if I'm running P3 first, P3 will run completely. And if P3 will run for complete 3 duration, P4 will have to wait for 3 duration. But I cannot tolerate that. I cannot tolerate that. Why? Total waiting time will become 1 plus 1 plus 3. Total waiting time will become 5. I cannot have more than 4. No, not possible. So what I'll have to do is I'll have to run P4 first here, and that too I can run for exactly 2 duration of time. If I run P4 for 2 duration of time, P3's waiting will increase by 2 more duration of time, 3. P2's waiting 0, P1 waiting 0, P4's waiting 0. Run completely P4, which implies Z equals to 2, and after that you run P3 for 3 duration of time till 9. Waiting time of P4 and P2 0, 0, P1 1, P3 3, total waiting time 4, Z value equals to 2. You will have to put up little mind. थोड़ा दिमाग लगाना पड़ेगा. You will have to use this brain, intelligence to solve such questions. And similar kind of intelligent question has been asked in 22 GATE. This was also an amazing question. I loved this question. बढ़िया था, of course ये बढ़िया है. And this one is also really good, which I have shown on the screen now. This question should not take more than 2 minutes. Okay, let's say 3 minutes. Sir, I always suffer from this question, sir. Explain more deeply if possible. I will. Q should be greater than 8. This logic is correct. For remainder of the things, yes. Yes. You need to have the aptitude mind. If you have the aptitude mind, aptitude brain, then you will be able to find out the differences easily. You tell me, in the round robin, if quantum time is 4, a process runs first, P, one time only if process is running, that's it, only one time. What should be the burst time of P? What should be the burst time of P? Can P run for 1 time unit? Yes. Can P run for 2 time unit? Yes. Can P run for 3 time unit? Yes. Can P run for 4 time unit? Yes. After that, can P run for 5 time unit? No. If quantum is 4, P cannot run more than 4 at a more than once. At a time, more than 4 not possible. So P runs once. If again P comes, let's assume if again P comes, again it will run between 1 to 4 at a time max, not more than that. Right? Right. So based on the given information, what I'll have to do is I'll have to make a Gantt chart, and that will make my answer easy or my question easy to answer. See, PQRS scheduled on CPU as round robin algorithm with quantum time 4. Processes arrive in PQRS at time 0 in this order. So if processes are arriving, every process will have at least one burst to run, 0 to whatever. One time each process will run P to Q, Q to R, R to S. Now whatever they will give, I will make it possible. There is exactly one context switch from S to Q. How is possible that S to Q there is a context switch? After PQRS, if I run again P and then Q, then there is no any direct context switch from S to Q. So if I will run after S, Q, R again like this, which means P, it executed once and after that completed. PQRS, P only one time completed and done. After that QRS. But should I have QRS further or not? I'll have to check it over here. Okay, exactly one context switch from R to Q. Means after Q, I will run R and from R to directly Q. Which means after one time running PQRS, that's it, P done. From Q from S directly to the Q, then R, then not S. Why? After one time running, S also completed. If S also completed, after PQRS, I am running QR. So there is a context switch from S to Q and there is a context switch from R to Q. How is it possible R to Q? I'll have to run again Q. So P and S one time done, QR second time running and Q third time running, so that I can have a context switch from R to Q. Exactly two context switches from Q to R. Q to R1, Q to R2, exactly two context switches, not more than that. So after Q, that's it. My execution is over. This is my this is my Gantt chart. In this Gantt chart, how many times I'm running P? P I'm running only once, one time. Q, how many times I am running? 1 and 2 and 3 times. R I am running how many times? 2 times. And S I am running how many times? Only one time. If you are running a process only one time and completed, which means P should have burst time equal to 4 or lesser than 4. So whatever quantum we have or whatever burst time we have of process P should be between 1 to 4. So that once P runs and done. Q 3 times. If you are running Q 3 times, 2 times you will have to run Q maximum possible. Maximum possible means 4 burst here, 4 burst here. 4 plus 4, 8 and again Q you are running here. So last time Q here can run for 1 time, 2 times, 3 times, 4 times, anything. So my burst time of Q should be between what? Between 9 to 12. Cannot be 8. Should not be 8. Why? If Q is having burst time 8, 4 here done, third time I will not require Q again. Vikas, it's wrong. Understanding what am I saying? Q should have its burst time greater than 8 maximum 12. 3 times only Q is running. That's it. Now next, R you are running 2 times. If first time you are running full 4 time unit, you will have to run. That is my round robin algorithm. And after that here, next time, last time you are running, I can run it for 1 time, 2 time, 3 time, 4 time. Means R should have its burst time between 5 to 8. S only 1 time means 1 to 4. Let's see the options. P 1 to 4, no issues. Q, oh, issue. Here should be greater than 8, lesser than equal to 12. Option A, B, C are fine, but D is having a problem here. Q 7 given. R between 5 to 8. Yes, fine, no issues. S between 1 to 4, no issues. Option D is correct. This is what the detail. Another question. You guys are okay, right? I have just shifted to the next question, understanding that you guys understood everything in the previous question. No time waste here. You all know, right? This particular given numbers, these given numbers are not the page numbers. These are the virtual addresses. Virtual address. From virtual address, you will have to calculate the page number. Moreover, these numbers are given in decimal. If virtual address is given in decimal, how to get the page number from it? Yesterday we have seen the formula. Yesterday we have seen the formula. How do you get page number? How do you get page number? It's easy. Page number is equal to virtual address divided by page size, and that too in floor value. Okay, now If I go with the page number, these all will go in the page number 0. Okay. Next, these two will go in page number 1, 2, then again 0, 5, 1, 2, 5. This is the page reference sequence. All the addresses belonging to single page I have written once. 3 बार 0 क्यों लिखा? कहाँ लिखा 3 बार 0? क्यों नहीं लिखा? Just because I do have hit for remaining two addresses anyway. If 0 will have page fault, after that page hit will be there anyway. I don't have to count hit here, right? Page faults only I'll have to counter. So I don't have to worry about multiple times if I write, doesn't matter. So this is my page reference sequence. What happens in that case? For main memory with only 4 pages, main memory can contain only 4 pages. For 0, page fault is there. For 1, page fault is there. For 2, page fault is there. For 0, no page fault. For 4, page fault is there. Replacement policy, which one is used? Given in the question? LRU policy, okay. Then for 5, I will keep 1204. No, I'll keep 204 and I'll remove 1. I'll remove 1 for 5. For 1 again page fault, I'll remove 2. For 2 page fault, I'll remove 0. And for 5, no page fault. So how many page fault? 7 page fault. And what are the pages? 1, 2, 4, 5 are present. 1, 2, 4, 5, 7 page fault. Option B is correct. Seven page fault, option B is correct. 7 page fault and 1, 2, 4, 5 are present in the main memory. Check it out. If any doubt, just let me know. If no, then we'll go ahead with the next question. Next question. Wow, this is so good. 0, 1, 2 वाली लाइन में confusion हो रहा. क्या confusion है? What is the confusion? Can you please tell me? What is the confusion? What is the confusion? This virtual address by page size is 16 byte. Every value you divide by 16, take the floor value, you will get page 0, page 0, page 0, page 1, 1, 2, 2, 0, then 4, 4, 5, 5, then 1, then 2, then 5. That is how I get this line, this formula. Now mathematics, if I will tell you how to apply formula mathematics, dividing this by page size 16, I'm really sorry, but I cannot do that. Each virtual address I have divided by page size 16 byte. This is the formula I have written. From there I'll get page number, which page number that particular address belongs to. 0, 0, 0. And this division is simple mathematics. I'm really sorry, with my hands folded, I cannot teach you mathematics of that level. I am not that pro teacher. Seriously. Okay. Let's go with this question. This is very easy question, yaar. Very, very easy question. But it is tricky. Can't apply same concept of set offset similar to this here. Set offset? There is no any mapping concept over here. In the cache, we have the mapping concept. Here is not mapping concept we have. Now, cache and pages work differently, beta. There is no any mapping concept. We just bring the pages. Virtual address, from virtual address anyway we will have to get the page number. There also, if main memory addresses are given in the cache, we will have to first calculate the block number, just because mapping belongs to our mapping are applied on the block numbers. We cannot do shaggy. What question says? Consider an operating system capable of loading and executing a single sequential user process at a time. Uniprocessing system. At a time, only one process. The disk head scheduling algorithm used for is first come first serve. If FCFS is replaced by SSTF, claimed by the vendor to give 50% better benchmark results, what is the expected improvement in IO performance of user program? Answer will be 0. Why? See, multiple requests if are pending, then my FCFS, from FCFS SSTF can do better. But if only one request is pending for the disk, every algorithm will work same to same. Yes, question says that we have a single sequential user process at a time. One user process will have one request only of the disk at a time. So for one request, does not matter if it is FCFS, scan, first come first serve or whatever, same will be performed. All the request, there is no any improvement at all. There is no any improvement at all from FCFS to SSTF. Why? Just because only if one request is pending, my head will go that direction only, at till there only, whether it is FCFS or SSTF. So no any improvement we can have. All 0. Next question. Very easy question. Very easy question. Question is really good. Yes. That's why I have brought here, just to increase your knowledge. Also, this data would not sufficient for more than one process, right? Yes, of course. For more than one process, so definitely we should have. Oh, for one more than one process, directly 50%. Directly 50%. Tech bro, 50%. Consider following 5 disk access requests. Form request ID, cylinder number, and PQRST. Head is positioned at cylinder number 100. Okay, so let's go with this. Request, whatever request we are having, I'm just marking them on the sequence 30. Then this is S. Then next is 85, which is Q. Then we have 110 R, 115 T, and P, 155. My current head is at 100. Scheduler need uses SSTF. Let's do SSTF from 100, which is closer. 85 is at 15, 110 is at 10. This. From there, 115. Okay. From 115, this is 40 distance. This is just 30 distance. So we will go to 85. From 85, this is just 55 distance. This is more than 55. We'll go to 30 and then at the end 155. This is the way we are servicing. T is serviced before P. T, yes, is serviced before P. P कहाँ है? ये रहा. Yes, of course T is serviced before P. This is true statement. True. Q is serviced after S. Q is serviced after S. False. It is a false statement. B is a false statement. Q is serviced after S. No, Q is serviced before S. Next. But before T, false. Anyway, false. The head reverses its direction of movement between servicing Q and P. Where is Q? Here, and P here. Between that, yes, direction change happens at 30. So yes, true. It is true. This statement is true. R is serviced before P. R is serviced before P. True. Of course. Of course, true. So only one option is false, which is B option. If 85 replaced by 75, if there is a tie, they will always give you a tiebreaker in the question. Always. They will always give you a tiebreaker that which particular way you will go, either right or left. In the question, they will mention a tiebreaker. You don't have to worry. In the gate question, always given the tiebreaker. In the test series question, I don't know. Wow, another question. GATE 2018, one of my favorite one. I am cooked. Okay. Serve yourself to somebody who can eat you then. "15 more days, Prathamesh. Just 15 more days and done." अरे इतना मैं समझता रे. I understand that much. Cooked means exhausted. If I am teaching to the young guns, the Gen Zs, I understand a few words of Gen Zs. At least this much though I understand. Of course, I am very older to you than you guys, but I understand. 15 more days. This is what needed by gate preparation. If somebody can take up that much of pressure, that fellow will definitely be at really good place. I look 16 ना रे, इतना झूठ मत बोल. Okay, what the question says. Consider a storage disk with 4 platers. Consider 0, 1, 2, 3, 200 cylinders numbered 0 to 199 and 256 sectors per track 0 to 255. The following 6 disk requests are in the form: first sector number, cylinder number, and then plater number. Usually what happens? We have cylinder number, plater, and then sector, but they have just jumbled it. Cylinder number is in the middle. Currently, head is positioned at sector 100 of cylinder 80. Head is at 80. Cylinder 80 of sector 100 of cylinder 80 and is moving towards higher cylinder number. The average power dissipation in moving the head over 100 cylinders is 20 milliwatt and for reversing the direction is 15 milliwatt. Power dissipation of associated with rotational latency in switching the head between the different plater is negligible. So head movement through the cylinder only taking the power. So I'll have to just calculate that only. Total power consumption in milliwatt to satisfy all of the above requests using the SSTF algorithm is how much? So let's do one thing. First, cylinders. How many cylinders you are having? How many cylinders we have? 200 cylinders 0 to 199. On those, let's mark out all those pending requests: 16, 20, then 70 to 86, 80 in between just because currently read write head is at 80, 116, 134. Currently read write head is at 80, moving towards the larger direction side, and we will go towards this side only just because 86 is closer than 72. From 86, 116, how much? 14 and 16, 30, but this is closer. From 72, this is 52 and this is how much? 28, 72 say 82, 92, 102, 112, 104, 44 distance only. So 116 is closer. Now after 116, 134 and then change the direction 20, then 16. This is the way you will have the entire all the services done. Now how many number of head movements we will have? First we are going from 80 to 86, 6. After that 86 to 72, which is 14. Then 72 से 134, 72 to 134 is 62. Then 134 to 16, which is 124. 118. 6 4 10 2 12 और 8 20 3 100 total head movements. Total head movements are 200. 100 total head movements are there. Now question says what? For every 100 head movements, 20 milliwatt is needed. For 120, then for 200, how many? So total power dissipation is 200 multiplied by 20 divided by 100 milliwatt. Plus, for every direction change, 15 milliwatt. How many times direction change? 1, 2 and 3 times. Here at 80, no. Why? Just because head is moving towards the larger. Look at this. Moving towards the higher cylinder number only. Given in the question, moving towards the higher cylinder number. So at 80, already I am going towards higher number till 86. No direction change at 80. 3 times direction change. Each direction change takes 15. 40 plus 45, 85 milliwatt. That is the answer, 85. Of course, to understand the question and solve it, that is what the need of the hour. In the GATE examination only, you will have so many such questions which will be very easy if somebody else will explain you. But can you make it? That is a big question. And that is where your practice will help. Okay, first you solve this question. Very easy. We have solved this question before. एक बार डायग्राम दिखा दो ना सर, आर्किटेक्चरल का किस चीज का डायग्राम दिखाना है? किस चीज का डायग्राम दिखाना है? You know, I love those guys who know the answers of PYQ. But if a new question has been asked, those guys are disappeared. So those guys will only answer when they remember the answer of some questions. Directly they will post without even solving. Sir, this question answer is this. I am impressed, bro. And to impress me, what you will get? GATE rank. My money. Gadbad. To get the GATE rank, you will have to know the concepts, how to solve the question, rather than just remembering the concepts and remembering the answers. You are very chalak, bro. लास्ट सेक्टर क्वेश्चन के सेक्टर सिलेंडर प्लेटर का जरूरत नहीं है. Just because in the last question the power dissipation happens only while moving the head between the cylinders. Rotational latency and moving the head between the platers, power dissipation is not calculated, so we will ignore it. System with 3 processes that share total 4 instances of same resource type. So total 4 instances we have, and those 4 instances are shared between 3 processes. Each process can request a maximum k instance. Resource instance can be requested and released only once at a time. The largest value of k, that will always avoid deadlock. So we know the concept, right? When 3 processes are there, each require k, give 1 less to each process, then plus 1. This should be lesser than equal to total resources I do have, which is 4. 3k minus 3 less than equal to 3, 3k less than equal to 6, k less than equal to 2. K value should be either equal to 2 or lesser than 2. Largest value of k they are asking, maximum of k is equal to 2. That is the answer. Sir, your chat is very behind. No, it is not behind. I am not reading. Next question. Beta, the diagram is same to same which we see for the disk. If you know the disk, you can understand. Disk platers and arm, etc. is there, right? That. Are you guys aware of some news going on? Some news or something do you hear? You know, there is a news floating around that there is a person who was a BTech graduate from IIT Bombay in aerospace engineering. Then he has left his high paying job and has become Baba. And he is at Allahabad right now, Prayagraj for Mahakumbh. See, IIT tag matters. If you wonder why IIT tag, etc., etc., IIT tag matters. Here also, there are n number of Babas over there, n number of saints and sant are there, but only a few members are getting viral. One among them is this person who is from IIT. People are not going to him for taking blessings or something. People are going to him just for the interviews and talks. Why, how, etc. How was that, etc. Here, IIT tag here also matters. So whoever says na, that what is IIT tag, etc., what it can give me, etc., etc., tell them. Answer. This question's answer. Consider the following snapshot of a process running n number of processes. Okay, n number of processes are there. Process I is holding xi instances of resource R. I is between 1 to n. So there is a process I which is holding xi number of resources. Currently all instances of R are occupied. So there is no any instance of R available. All are occupied, available is 0. Further, for all I, process I has placed a request of an additional y instances while holding I instance of already it has. Okay. So process has already some instances and it has initiated request for y more instances. There are exactly two processes P and Q in such a that YP and YQ are 0. Means, look at this. Two processes are there. Let's say P1 and P2. This process is having x1, this process is having x2. Okay, P and Q processes are there, so I can say P and Q processes are there. P already having x instances of resources, Q already having x number of instances, xq already there with them, and P has requested for y instances, yp and yq. But if request is 0, look at this, both P and Q's request are 0, no any request is there, P and Q complete without any waiting. Can complete? Yes. Which one of the following can serve as a necessary condition to guarantee that system is not approaching to a deadlock? Among these conditions, which particular condition will tell you that towards deadlock the system is not approaching? So what I'll see, two processes P and Q if we are having, P is holding xp, Q is holding xq, P requested for yp, Q requested for yq, but request is 0. Request is 0 means P and Q is not even waiting and requesting for any resource they can complete. When they will complete, they'll release their resources. P will release xp, Q will release xq. So after P and Q completes, available resources will be how many? My available resources will be xp plus xq. Why? Just because before P and Q clear cut mentioned that all instances of R are occupied, so there is no any instance available. There was no any instance available before P and Q completed. Now after P and Q completed, all instances which given to P and Q are free. Now if P and Q are releasing xp and xq, these are the total available resources. With these resources, can I complete the request of another process? If yes, then I am going further and in the correct direction without deadlock. If with these many instances, if I cannot fulfill somebody's request, then there is an deadlock approach. Okay, so what I will write, this particular xp plus xq should be greater than or equal to request of some process which is not P and Q for sure. So look at this minimum of some process yk. Some process is k, that particular process's request is y. Yk's, if any process is having k process, any k process is there that is having its request, and among all the request, minimum request is lesser than equal to this, I can fulfill that request and I can complete that process. But of course k should not be equal to this P and Q. Other process, B option, is saying that deadlock is not approaching. We cannot guarantee that deadlock is not there, but we can say that yes, progress is fine. Progress means towards the checking of no deadlock, progress is fine. That some process is there whose request y is still lesser than or equal to available resources. That process will complete and will release its x, means in hold instances, and we are fine. We are done with all the PYQs which we wanted. Time is also almost done. 3 hours I have thought we'll do a lot of PYQs. Now we will meet at 7 p.m. on GATE Wala ECCS channel, and we will continue with the Mahabhyas, a different type of questions which we will try to solve over there. रैंक आ जाने के बाद हम मिलेंगे बिल्कुल, आइए जी. Sir, single IIT tag itself can change many circumstances, but to make it, to make the IIT tag, what you guys will have to do is you'll have to work a lot. You'll have to work a lot. And when you work a lot, your attitude changes. When your attitude is to, not give up, to work harder in any situation, you will succeed in any place you go, and that is why it matters. And of course that IIT tag, when it is attached, of course it is giving you, or it will give you a lot of preference over others. You will be given preference. सर डर लग रहा है, कुछ चीजें तो बिल्कुल ब्लैंक है। ललित कुमार जी, डर तो लगता है, हर किसी को लगता है, हर किसी के साथ ऐसा होता है। लास्ट 15 डेज हैं और रिवीजन प्रैक्टिस टेस्ट करते जाइए। जितना ज्यादा मेहनत करेंगे उतना अच्छा रिजल्ट। एज मच एज पॉसिबल यू जस्ट कंटिन्यू कंटिन्यू कंटिन्यू। एवरीबडी इज अफ्रेड ओवर हियर। ओके, थैंक यू सो मच once again. See you at 7 p.m. Bye bye everybody.